Hey guys, so today we're going to be talking about how to find decibels. It's going to be somewhat similar to what we did for magnitude. So our learning target for today is going to be calculating the difference of two sounds in decibels. Alright, so a decibel, which is notated by dB, is a unit of sound intensity on a scale from 0 for the least perceptible to, sound to about 150 for severe ear damage. A decibel equals 1/10 of a bell, which is a unit named after the famous inventor, scientist Alexander Graham Bell, pictured right below here. Here on this table, you can just see a few examples of the different decibels and the noise that goes with that value. Anywhere from fireworks being 140 decibels to raindrops or a quiet room being 40, and even whispering is 20. All right, so sound intensity is a type of power density measured in watts per square meter and is written with a W over meters squared, same thing. So the number of decibels for a sound is 10 times the number of bells and is given by the formula. So the 10 times, that comes in at the beginning of our formula, it's 10 times the log base 10 of the relative loudness equals a value, and we'll talk more about that in just a second. We'll put that decimal value there. Okay, so this is our first example. The best way to kind of explain how to use the formula is just kind of jumping in and doing it. If a jet plane is 120 decibels and a truck is 90 decibels, how many times louder is the plane compared to the truck? So we're going to create a ratio, and so I'm going to go over to the side. I'm going to put what we're comparing. We're comparing a plane with its loudness with a truck. And so since this is our comparison, this is kind of going to drive us to know how to set up the equation. I'm going to go ahead and create two of them. I'm going to do the plane. So I'm going to go ahead and set that up. So remember, the formula was 10 times log base 10, and understand that log base 10 can be just written as a log of, and we're comparing the plane right now that has a decibel of 120. And then in the denominator, we're trying to refer to the trucks, which is 10 times log base 10 of t, because we're going to find out what the truck is, equals the 90 decibels. Okay, so now we're going to solve for p and t, and we'll do that kind of simultaneously. On the top, remember, both of these are going to have to be divided by 10. This is an equation in the numerator and the denominator. So on the top, I'm going to divide the left side by 10 and the right side by 10. And the denominator, I'm going to do the same thing. I'm going to divide both sides by 10. So that'll take care of the tens. And then I'm going to go down and kind of do the next step, and we'll kind of write what was left over. So now we have the log base 10 of p equals 120 divided by 10 equals 12 over log base 10 of t equals 90 divided by 10, which is 9. And just like magnitude, we talked about how we can turn a log into an exponent. So I'm going to take the base and get rid of the log and the 10 on both sides. So now I'm going to look and see what we have. So now we know the P for the plane is going to be 10 to the 12th power over the truck. Loudness is 10 to the 9th power. Remember, when we are dividing, we are subtracting the exponents because our bases are the same. So we now have 10 to the 3rd power. And again, we're looking for the loudness, how much louder the plane is than the truck. And if you remember, the 10 to the 3rd power means that we're going to have 3 zeros in our answer. So you can say that we have you can actually say that the plane is 1,000 times louder than the truck. There you go. All right, on to the next. All right, so for example number 2, in this problem, it's just talking about 2 different tones. One is registering at 45 decibels and the other is 25 decibels, and they want to know what the comparison is. So we just have 2 different tones. So we'll say we're going to compare tone 1 over tone 2. And I'm going to go ahead and set up the formula pretty easy. I think some of the steps we can catch on pretty quickly. So the first one on the tone 1, we're going to say that we have 10 times the log base 10 of, we'll say T1 for tone 1 equals 45 over 10 times the log base 10 of tone 2, so little T subset 2 equals 25. Now, I'm going to go ahead and go down to the next step. We talked about a second ago that you're going to divide both sides of this function by 10. And so we'll just kind of do that all in one step. So the top in the numerator, we're going to have what we now have log base 10 of T subset 1 equals 4.5 over log base 10 of tone 2 equals 2.5. And then just a second ago, I reminded you just very magnitude. This is where we're going to turn this log into an exponent. I'm going to put my little 10s down here. So the 10 log base 10 will go away. The 10 log base 10 go away down here. And now we have 10 to the 4.5 power over 10 to the 2.5 power. You subtract our exponents, and now we have 10 to the second power, which we now know with second power means 2 zeros. So that is a 100 times louder. That would be tone 1 is 100 times louder than tone 2. All right. Hopefully that helps. All right, so the assignments, if you want, you can do a couple different ways. You can either pause the video and work through it, or you can access the PDF version on the calendar at the week at a glance so that you can easily access this information. Or you can actually go to the digital version of the book that's also in Moodle, and when you click on the link, you can just go to page 69 and you can find it on numbers 33 through 36. Good luck.